Welcome everyone. Today we're diving deep into Ethereum sharding, a fascinating approach to scaling blockchain networks by splitting them into smaller, manageable parts.
Yep, I'm with you on that. It's really interesting how sharding, which originally comes from database systems, is being reimagined for blockchain, right?
Absolutely. It's like taking a gigantic workload and breaking it into little pieces, so each piece handles its own transactions.
Definitely.
This isn't just about making things faster, but also about reducing issues like those high gas fees that have been a headache on Ethereum.
Yeah, I was struck by how sharding can actually lower gas fees because fewer transactions compete on the same chain.
Right, exactly. Currently, Ethereum only processes about 13 transactions per second, and with sharding, they're aiming for some estimates suggest up to 100,000 TPS, although that figure might vary until full
Wow, that's a
implementation.
massive leap. And the underlying principles are equally intriguing. The concept takes inspiration from classical database sharding, where shard means a small part of a larger data set.
Yep, it's like um, you're dividing an enormous ledger into 64 linked databases in Ethereum's case. Each shard is kind of like its own mini chain, processing transactions concurrently.
Right, so parallel processing becomes the key. I find it really clever. Instead of every node having to handle every single transaction, nodes are segmented into shard chains, or more precisely, shard blobs with dank sharding.
Exactly. Dank sharding is the new twist here. Instead of traditional shard chains, Ethereum is moving towards these blob structures, with each blob consisting of data, and every blob validator group, I mean each committee of 128 validators, processes and confirms transactions every 12 seconds.
Exactly. It's almost like having several mini networks inside one grand network, each doing its own thing while communicating with the others.
Yes, and that communication between shards is crucial. They need to stay in sync, otherwise, we'd have issues with consistency and security.
Absolutely. Speaking of security, there's always that worry about attacks that could span multiple shards, right?
Exactly. Cross-shard attacks are a big concern, but Ethereum is addressing that by randomizing validator assignments and using techniques like data availability sampling, where you verify massive data sets by just sampling a few nodes.
That's pretty reassuring.
And don't forget, sharding also supports decentralization. Rather than having super expensive requirements for every validator to store an entire chain, now anyone can potentially run a node on a laptop
Right, that
or
could
even a
really
mobile
open the
device.
door for more global participation. It's almost like bringing blockchain closer to everyday use, not just for tech giants.
Exactly. The whole idea is to create an environment where more nodes can join without needing high-end hardware, which inherently boosts security and
Yep,
decentralization.
the more distributed, the better. Now, one point that really caught my attention was the way sharding works alongside layer 2 rollups. Isn't that so?
Right. Sharding and rollups are a powerful combination. While shards handle transaction processing, rollups take care of storing state data off-chain. It's like delegating duties to make sure the network runs smoothly.
That kind of synergy is really smart. But I do have a thought here. Don't you think relying on off-chain storage might introduce its own set of complexities or even, potential vulnerabilities?
That's a fair point. There's always a trade-off when integrating off-chain components. However, the added cryptographic proofs and techniques like zero-knowledge snarks could mitigate these risks by verifying transaction validity without exposing sensitive details.
True zero knowledge proofs are a game changer.
Exactly. And look, even if shards initially don't handle smart contracts directly, the plan is to gradually introduce functionalities as the network
That's an
matures.
interesting evolution. So, early shard chains might be mostly for extra data support, but down the road we could see shards that execute code and manage transactions fully, right?
Yep, that's one of the possibilities. There's been debate on whether shards should simply be data depots or evolve into full execution environments, making cross-shard communication even more critical.
Ensuring smooth cross communication will be essential.
And cross-shard communication might be streamlined using advanced cryptographic methods like zero-knowledge snarks to securely verify transfers between shards without too much overhead.
Definitely, that could balance functionality with security. I also appreciate how sharding, by reducing the central data load on individual nodes, could really help lower those energy requirements. Much like the shift from proof of work to proof of stake did in the merge upgrade.
Right on, the merge was a revolutionary step that cut down energy consumption by 99.95%. Sharding is an additional layer of improvement on that front, making the network more efficient and sustainable.
It's all about sustainability now.
It's honestly a holistic approach to scaling, not just cranking up transaction numbers, but also considering decentralization and cost efficiency.
Exactly, a truly multidimensional upgrade. But here's a challenge. With shards managing different segments, there's a risk of data fragmentation. Some might argue this could weaken the network's overall integrity.
That's a valid critique. Maintaining data integrity across shards is no small feat. Ethereum is countering that by ensuring regular communication and consensus across shard committees, which reduces fragmentation risks.
Balance is key.
Totally. And it's this balance between decentralization and efficiency that's truly fascinating. On one hand, you want every node to be lightweight and accessible. On the other, you need robust security to fend off potential
Yes,
attacks.
it's a delicate dance between scalability and security. And the interesting thing about sharding is how it might democratize network participation. More users, less technical entry barriers, it could really transform blockchain adoption.
Exactly. Imagine running a node on your laptop or phone without needing a powerhouse computer. That opens up decentralized participation to a broader audience, which in turn
It's like
bolsters the whole
leveling the playing
ecosystem.
field.
And, if you think about traditional financial systems, the idea of decentralization here is pretty revolutionary, moving away from the central authority model to a more distributed, community driven setup.
Definitely, it shakes up the old guard. I'm also curious about the potential business impacts. If Ethereum sharding gets fully implemented, it could pave the way for blockchain to handle massive transaction volumes, rivaling systems like Visa or PayPal.
Absolutely. Imagine decentralized finance, global supply chains, and shared value networks operating seamlessly at such transaction speeds. It could unlock entirely new use cases and business models.
That's a pretty exciting prospect. And it's not just about high speed, it's about creating a robust network that's far more accessible, secure, and environmentally friendly.
Right, it's a holistic upgrade. Improve speed, lower costs, enhanced decentralization, and better security mechanisms all wrapped into one.
Definitely a win-win scenario. With all these considerations, it seems like Ethereum sharding is set to be a game changer, even if challenges remain in the transition phase.
Yep, and while there are still debates about how much functionality each shard should have, it's clear that the foundational benefits, speed, scalability, and enhanced security, make sharding a pivotal evolution for Ethereum.
Absolutely, the future of blockchain looks bright with these innovations. In the end, Ethereum sharding isn't just a technical upgrade, it's a paradigm shift that could redefine what we expect from decentralized networks in the years ahead.